Hello, good morning to all of you. So, welcome to the first lecture of Stereo Machine here. In today's class, we have to start our new topic that is simple mechanisms and the motion analysis of mechanisms here. Okay. So, first of all, theory of machine is going to be a very important subject for you, in which we have to see total of 9 chapters here, including mechanisms, their motion analysis of velocities and acceleration, gear and gear train, cam and follower. Okay. Then we have to see the static and dynamic balancing, static and dynamic analysis here, balancing part, gyroscope here, okay, vibration parts. All of these topics we are going to cover up in the theory of machine portion here. Okay, now. So now let us start with our today's topic here. So first, let me tell you that what is the meaning of mechanisms here. In the what we have to study in the first chapter, that is simple mechanism. In the simple mechanism, we have to talk about the simple machines here, how the machine development has been done. Okay, so the machine development is going to be uh, long back before the definition of the simple link here. So from the link definition of the link or a simple uh, body here, we can define the mechanisms here. So first we have to see the definition of the link. Then we are going to see that whenever two links are going are make a joint here, then it forms a pair. Okay, then we are having a formation of pair, or I can say it is a kinematic pair. Now, when the number of links are joined in such a way that the first and the last link are connected with each other, in that case we have a formation of a chain. Now the chain can be either the kinematic chain or a non-kinematic chain here. So we are going to talk about the kinematic chain also, as well as we are also going to talk about the non-kinematic chain here. Okay. So once we find out that our chain is a kinematic one or a non-kinematic one, we can proceed to the mechanism part here. So in order to create the mechanism from the chain, what we have to do, we have to fix the different number of links here. Okay, now. So here you are going to see that we are going to fix the number of any one link out of the number of links here. Okay, to obtain a mechanism. Now, when we combine the number of mechanism, it forms a machine. Okay, so there is a proper sequence of studying this particular chapter here. First, we have to talk about the definition of link here. Then we are having pair, kinematic pair, chain. Then we are having mechanism, machines, etc. Okay, now. Now, coming back to the next part. So let us start with the first part here. Let us see the question itself. What are the important terms here? So first question is that the mechanism used in a shaping machine is okay. So first of all, just see what is mechanism. Mechanism is generally obtained by fixing the one link of a kinematic chain here. Now, what is the meaning of chain? Chain is a group of links in such a way, connected in such a way, the first and the last link has to be connected with each other. Okay, now coming back to the third case, what is the meaning of link? So basically, the kinematic link is considered the links in a machine are considered are those part here which is having a relative motion between them. Okay, that you have to remember. For example, if you are having a simple piston cylinder arrangement, in that case you can see first you are going to observe that crank is rotating about point number one here. Okay, so this is our simple piston cylinder arrangement, like in this case. So now I can say here the the point number A about which the crank is rotating is going to be considered as a fixed link because it does not move at all. It is acting as a frame, as well as the cylinder is also acting as a frame here. So cylinder and the point A is on the frame here, so it can be considered combinedly as a one link here. Okay, because it does not have any relative motion between them. Now the crank can be considered as a link number two. Why? Because crank is having a pure rotary motion about the point number A. So it is having a different motion here. Then we are having a connecting rod. Connecting rod is going to be considered as a third link. Okay. Similarly, you are going to see the piston is acting as a link number four. Okay. So in this way, you can just define the number of links in a kinematic chain here. So in order to define a number of kinematic chain, we have to see that how many links are having a relative motion between them, and after that we can simply do the calculations of the link here. Okay, now next part in this case. Now what is mechanism? Now in this case you can fix the any number of links here. Either you can fix the link number A, Either you can link the I can say cylinder here or piston here, connecting rod here or crank here. You can fix any link out of all of these links here, and we can obtain a different type of mechanisms. Understood? So, in the theory of machine first chapter, simple mechanism, here we talk only about the planar mechanisms here. Planar mechanisms are also considered as a simple mechanisms. It is having the characteristics that it is having a number of link as 4 and the total number of joint as 4 here. Now, out of this total joint of 4, 4 can be considered as a turning pair. Either 3 can be turning pair with one sliding pair, or either we can have two sliding pair plus two turning pair. Okay, we may have any combination here. Now, in this case, you are going to observe that uh, we are having a different type of mechanisms here. For example, we are going to see a 4-bar mechanism. So when we talk about the type of simple mechanism, here we are having a simple 4-bar mechanism. Then we are having a simple single slider crankshaft mechanism. Then we are having a double slider crankshaft mechanisms here. Okay. So all of these mechanisms are defined on the basis of how many turning pairs are there and how many sliding pairs are there. For example, in the case of 4-bar mechanism, you are going to see all the four turning pairs. In the case of single slider crankshaft mechanism, you are going to see two sliding pairs plus three turning pair with one sliding pair. In the case of double slider, you are going to see two sliding pair with uh, three turning pair with one sliding pair. Oh, sorry, what I am saying. In the case of single slider, you are observing three turning pair with one sliding pair. In the case of double slider, you are observing two turning pair with two sliding pair. Okay, that you have to remember. Now, if we talk about the inversions here, what kind of different mechanisms you can obtain? Let us suppose if we talk about the 4-bar mechanism, in that case, we may have a we may have a simple crank rocker mechanism, double crank mechanism, double rocker mechanism like in this way. In the case of single slider crankshaft mechanism, you may have a formation of reciprocating engine, reciprocating pumps, or I can say crank and slot lever mechanisms here, Whitworth Quick-return mechanisms here, like this case. In the case of double slider, you may have a formation of Oldham couplings, electrical primer, etc. Okay, now. And similarly, in the case of shaping machine also, we are using a one such mechanism, which is basically an inversion of a single slider crankshaft mechanisms here, which is considered as a crank and slot lever mechanism. So here you have to remember that in the case of shaping machine and in the case of a planar machine, we are using a crank and slot lever mechanism, which is basically a inversion of the single slider crankshaft mechanism here. Crank and slot lever mechanism. Okay. In this case, how many turning pairs are going to be there? Three turning pairs are going to be there with one sliding pair. Which link is going to be considered as a fixed one here? In this case, we generally fix the connecting rod. Connecting rod is basically the fixed link in the case of crank and slot lever mechanisms here. Okay, so that you have to remember. Now coming back to the next question. A planar mechanism has 8 link, 10 rotary joints. The number of degree of freedom of the mechanism using Grubbler criteria is going to be. Okay. Now what is Grubbler criteria? See, Grubbler criteria is used to calculate the value of the degree of freedom. By the way, it is also known as the pushback criteria. Okay, so here it is used to calculate the value of degree of freedom, or we can say the mobility of the linkage here. What does it tell us? So actually, if you just see the definition of degree of freedom, it may have a different type of definitions here. For a single link, or a single part, it tells us about how many independent motion it may have. For example, a 3D link, it may have a three translatory motion along x-axis, along y-axis, along z-axis. Along with that, it is going to have a rotational axis about x-axis, rotation about y-axis, as well as rotation about z-axis here. So I can say it is having a 3 translation plus 3 rotational motion. So I can say the total degree of freedom is going to be equivalent to 6 here. The number of independent motions are going to be 6 in the case of 3D link here. But in the case of mechanism, for example, let us suppose we are having a 4-bar mechanism here. Okay. In this case, I am assuming the link number 1 is fixed. So here, what is the meaning of degree of freedom? Degree of freedom simply represents how many number of inputs are being required to have a constrained output here. That is basically the definition of degree of freedom. So I can say the degree of freedom is representing you the number of inputs required to obtain a constrained output here. So it is having a formula f equal to 3l minus 1 minus 2j minus h. That is a formula here which we use, where l is representing you the number of link, j is representing you the number of binary joint, h is representing you the number of higher pair, and sometimes the redundant motion is also being present inside the mechanism, and we don't have to consider that. Okay, now? So here in this case, you can see in the question, it is given to us the number of links are 8. The number of links are 8 here, and the number of joints are 10 here, and number of higher pairs are 0, and there is no information regarding the redundant motion, so we are considering the FRS 0 here. Okay, so correspondingly, if you just solve it, you will find that degree of freedom is coming out to be 1. So here you can see if degree of freedom is coming out to be 1, that simply means we have to provide only one input. Just by providing one input, we can control the motion of each and every link here. That means only one input is being required to control the movement of any link in a mechanism here. That is the simple meaning of degree of freedom. Okay, now? So let us suppose if 2 degree of freedom is coming. So that means you have to provide two inputs. Next part. Which of the following is are the lower pair? Ball and socket, piston and cylinder, cam and follower, both A and B. Now just see. Whenever we define, but first of all, what is the meaning of pair? Pair simply means the connection between the two links. Well, whenever the two links meet at a single point, that is known as the pair or a joint here. Okay. Now, when we talk about the joint or pair, we are having a three type of joints here. Either we are going to have binary joint, or we may have a ternary joint, or quaternary joint here. Okay, so in this case, you have to remember that in the case of a binary joint, only two links are making a contact at a single point one here. In the case of ternary joint, what is happening? The three links are making a contact at a particular point. In the case of quaternary joint, four links are making a connection at a single point here. That is known as the quaternary joint here. Okay, and we have to remember that one ternary joint is equivalent to two binary joint here, one quaternary joint is equivalent to three binary joint here. That you have to remember. Okay. Now, whenever we do the classification, the classification is the first classification is the of lower pair, and the second classification, and the first is lower pair, and the second is higher pair. How this classification is being done? This classification is being done on the basis of the surfaces in contact here. On the basis of surface in contact. Okay, so if you're having a plane surface in contact, in that case, it is going to be considered as a lower pair. But if you are having a line contact or a point contact, then it is going to be considered as a higher pair. For example, in the case of piston and cylinder, we are having a surface contact. You can see if you are having a simple like this one, in this case, you are going to see this highlighted blue color is representing you the surface contact between the piston and cylinder. So I can say it is representing as a lower pair. In the case of ball and socket joint, we are having a curved surface, and inside it we are having another curved surface here. Okay, so here both of them are having the same curvature here. So correspondingly, again the surface contact is going to be made here. So I can say both A and B are going to be considered as a lower pair. In the case of cam and follower, we are having a point contact or a line contact. For example, let us say if you are having a knife edge follower. So knife edge follower is making a point contact at point number P, and that is going to be considered as a higher pair. Okay, now so that you have to remember. Next part. The length of the link of a 4-bar linkage with a revolute pair only are the. What is the meaning of revolute pair? Revolute pair simply means if two links are having a complete rotating motion, rotary motion about each other. Okay. So length of the link of a 4-bar linkage is R, P, Q, R, and S unit. Given that P is smallest, S is longest, which one of the link should be fixed for obtaining a double crank mechanism here? Now just see the concept of the inversions of a mechanism here. Inversion of mechanism. What is the meaning of inversion here? Inversion simply represents you the number of mechanisms obtained by fixing the different links here. Okay, number of mechanisms obtained by fixing the different links. By fixing different links here. Okay, so let us suppose if you are having a number of link as L, if the number of links are L here. Okay, so how many inversions can be obtained? So the number of inversions which can be obtained, it is always going to be less than or equivalent to L only. Okay, for example, in the case of 4-bar mechanisms, here I am assuming the S is the longest one, P is the smallest one, Q is this one, and R is this one. I am assuming this one. Just give me a second. So here in this case, S is the biggest link, P is the smallest link. Okay. Now, how you can find out that which type of inversion is going to be met? For that, first of all, we have to check out the Grashof condition here. So here we have to consider the first check out the Grashof condition. What does the Grashof law state that the smallest link the smallest length of smallest plus the largest, it should be less than or equal to, sum of the length of other two links. Okay, just remember this one. So here in this case you can see P is the smallest one, Q is the smallest one, P is the smallest one and S is the largest one. It must be less than the Q plus R. Okay, na? So here if I assume the Grashof condition is being satisfied, in that case, if the smallest link is being fixed, P is fixed, in that case you are going to obtain the double crank. What is the meaning of double crank? That input link and the output link both are going to have a complete rotation here. In this case, if P is adjacent to the fixed, P is adjacent to the fixed here. In that case, you are going to obtain the crank rocker mechanism. Out of the input and output, one is going to be oscillate and the second one is going to be have a complete rotation here. If P is opposite to the fixed, here, in that case you are going to see double rocker here. Okay, so you can see in order to obtain the double crank mechanism, what we have to do, we have to fix the smallest one. Okay, so I can say if the length of link P is fixed here, then only you can obtain the double crank mechanisms here. Okay, now so don't get confused, because in notes or in books here we generally take the S as the smallest link, but in this question P is marked as the smallest link here. Next part. A simple quick return mechanism is shown in the figure. The forward to return ratio for the quick return mechanism is 2:1. If the radius of the crank is O to A is 125 millimeter, then the distance between the crank center to the lever center point should be. Okay, now just see. Simple quick return mechanism is basically a inversion of single standard crankchain mechanism in which connecting rod is fixed here. It is basically used in the shaping machine and the planer machine because in this case the return stroke take less amount of time as compared to the cutting stroke, and our return is very quick as compared to the cutting. That is why. Okay, now in this case you are going to see uh, let us say this black color is representing the center point about which the crank is rotating here, which is marked as O2 point in the diagram, and O4 is marked as the second end of the connecting rod here. Okay. Now the crank is being positioned at point number O2 here, and the second end of the crank is at point number A here. Now, in this case, you are going to observe that crank is going to have a complete rotation. It is rotating like in this case. Okay, in this manner, the crank is rotating here. Okay, now. So, the crank is basically attached with a certain lever, which is marked with the black color line. Here you can see. So now I can say when the crank is rotating about point number O2, the slotted bar, it is basically oscillating about point number O4. Okay, so now you can see crank is having a complete rotatory motion, but connecting rod is going to, but the slotted lever is going to have a oscillatory motion about point number O4. Understood now? So that you have to remember. Now in this case, what is happening? We have to calculate the distance between the crank center to the lever center point. So we have to find out this particular distance x here. Okay. Now just see. I am assuming now the crank is making a 90-degree at this point. That means the lever is at the extreme end here. So now as the crank rotates and reaches this particular position shown with the dotted red color line. Now you can see during the rotation of, just give me a second. During the rotation of angle beta, the corresponding cutting is going to be there. Okay, because a slotted bar is moving from C to C dash. So I can say during this movement, the cutting is taking place. So as the crank is further moving from B to A again in the clockwise direction by rotating an angle of alpha degree, at that point of time, the slotted bar is moving back from C dash to C here. So I can say C to C dash is representing you the cutting stroke, and C dash to C is representing you the return stroke here. That you have to remember. So in this case, actually, that we define a quick return ratio, and the quick return ratio is defined as the time of cutting divided by time of return stroke. Okay, so here we know that beta is equivalent to omega multiplied by time of cutting, and alpha is nothing, it is equivalent to omega multiplied by time of return here, because crank is rotating with a constant omega. So I can say quick return ratio is there going to be beta by alpha here. Okay, now because omega is same, crank is rotating with a uniform angular velocity here. Okay, now the next part. Now, what is being given to us? Forward to return ratio is given to us 2:1. So if it is given to us 2:1, and always remember the cutting time is always greater than the return time. So quick return ratio is always having a value greater than 1 here. Okay, remember this condition. So in this case, I can write that beta is nothing but is equal to twice of alpha. Okay, so if beta is equal to twice of alpha, so now you can see from triangle O to A O4, I can write simply, what can I write? This angle here, na? Yes. Cos of alpha by 2 is nothing but it is representing you the AB upon O2 O4. I can say like that. So here I can say beta plus alpha is equal to 360 degree. So correspondingly, alpha is coming out to be 120 degree here. Okay, after solving. So now you can see cos of 60. Cos of 60 is nothing. It is equivalent to 1 by 2. Okay. 125 it is now. So I can say O2, O4 is coming out to be 250 millimeter here. So that's a very simple case. In most of the cases, in most of the questions of the quick return ratio, you are going to be given as the value of the quick return ratio as 1:2, and the corresponding angle value always come out to be 120 degree or 360 degree here. Okay, so you don't have to do the calculations here. Just use this values of angles here and solve it. It will save your time. Next part. A universal joint is an example of lower pair, sliding pair, rolling pair, and higher pair. So in the Curio machine, we have two type of joints here. The first one is known as the universal joint, which is also the alternative name of the universal joint is the Hooks joint here. Why do we use the Hooks joint or universal joint? To connect the two shafts, which is having the angular misalignment here. To connect shafts, shaft having angular misalignment. Angular misalignment here. Okay. Then we are having a this one here. Oh, sorry. Universal joint. Universal hook joint is the same one here to connect the angular misalignment shaft here. And second, we are having the Oldham coupling. Okay. Second, we are going to have a this one here, Oldham coupling. Oldham couplings are generally used to connect the two shafts which are having the lateral misalignment here. To connect shafts having lateral misalignment. So universal joints is finds application normally in the automobile engines to connect the propeller shaft with the differential. Okay, now just remember this part also. Whereas Oldham coupling finds its application in anywhere where you are having a lateral misalignment between the two shafts. So universal joint and the Oldham coupling both are having an example of a lower pairs only. Okay, now that you have to remember. Next, lead screw of a lathe with unit. The lead screw of a lathe with nut is an example of. It is considered as a screw pair. What is the meaning of screw pair? Screw pair simply means that if we are having a one link and if we are having the second link. So if second link is being rotating over the link number one and also along with the rotation, it is also translating over the another body. Then we say it is a screw pair. Okay, now. Next part. The kinematic planar chain shown in this figure is a. So what kind of chain it is going to have? What kind of mechanism it is going to be? So we have to find out. So first let us calculate the degree of freedom of this particular mechanism here. How we are going to calculate the number of the links here. So now you can see here in this case, this is going to be considered as the link number one. Okay, this is a fixed link. So this is also going to be the link number one, fixed link. Okay, because they don't have any relative motion between them, these two red colors. Now, this this blue color one is representing you the second link. This one is representing you the third link. This is fourth link, fifth link. Okay, now then we are having this yellow one, sorry, this gray one as a sixth link, this gray one as a seven link, this gray one as a 8 link, this gray one as a 9 link, and here we are having a slider. Here we are having a slider also. Okay, so this slider is going to be considered as a link number 10 here. Now, let us calculate the number of joints here. So if I calculate the number of joints here, in that case, how many joints are going to be there? Just see. First, here we are having first joint, then we are having second joint, third joint, fourth joint, fifth, sixth, seven, 8, 9, 10, 11, and here we are having 12, and between the number 1 and between the number 10, here we are having sliding joint, which is going to be considered as a 13 joint here. Okay, so I can say in this case, we are having the total number of links as 13, total number of link as 10 here, the number of joint as 13 here. If I calculate the degree of freedom, it will come out to be as 3L minus 1 minus 2 into J minus H. So correspondingly, answer will come out to be as 1 here. Okay. So what does the meaning of degree of freedom 1? That simply means by providing the one input, you can control the motion of each and every link here. Okay. So you are going to see how can we control the motion of these mechanisms here. So if you just apply the force, here, Okay, then what will happen? The entire, if you just apply the force at this particular position here, the entire mechanism is going to move in the downward direction here. Okay, now. So correspondingly, I can say the degree of freedom is going to be 1 here. Just by controlling the one input, just by providing the one input, you are controlling the each and every link of a mechanism here. Okay, now. Next part, in the single slider crankchain mechanism, the maximum acceleration of the slider is obtained when the crank is. Okay, just leave that question here because this question will be much simpler to you if you studied the static and dynamic analysis of a single slider crankchain mechanism here. Okay, I will cover that part there only. So just see it here. Just see some basic information that whenever the piston is sliding in the crank, okay, from number one position to number one position. So here you can see 1 to 2 is representing you the expansion and 2 to 1 is representing you the compression. Okay, now. So the movement of the piston inside the cylinder is from 1 to 2 or 2 to 1 here. So here we have to remember that at the extreme position, the corresponding acceleration is going to be maximum. So at point number 1 and at point number 2, the acceleration is going to be maximum. And at position number 3, the corresponding acceleration is going to be 0. Okay. And the point where the acceleration is maximum, there we are going to see the velocity is going to be 0. And the point where the acceleration is 0, we are going to see the velocity is going to be maximum here. Okay, so remember these conditions here. Why I am saying that we are going to check out in the static and dynamic analysis chapter here. Okay, now. So here you can see the single slider crankchain mechanism. The maximum acceleration of slider is going to be obtained at the inner dead center here. Okay, now at position number 2 here. Because at position number 1 also we are having a maximum value, but we are having a one more term relating to the obliquity ratio, which I will cover that in the static analysis chapter here. Okay, now because there we are having an analytical formula to solve the problem. Next part, which of the following statement is the correct one here? Is the incorrect here? Grashoff rule states that for a planar crank rocker Koba mechanism, the sum of the shortest and the longest link cannot be less than the sum of the remaining two links length. Inversions of mechanisms are being created by fixing different links one at a time. The Geneva mechanism is an intermittent motion device here. Grubler criteria assumes mobility of a planar mechanism to be 1 here. Okay. So out of this, only option number A. Yes, Ajit. Option number A is a correct answer. Okay, now just see what are the basic equations which you have to remember. First, the Goodback criteria you have to remember. Pushback criteria provides us the degree of freedom of the mechanisms here. Then we are having the Grubler's criteria. Grubler criteria basically deals with the definition of planar mechanism. Grubler criteria assume that the degree of freedom of a mechanism must be 1, the number of higher pair must be 0, then only you are going to see that simple mechanism is having a 4 number of links here. Minimum 4 number of links are going to be there. Okay, and there we are having a Grashoff condition. Grashoff condition state that the sum of the longest and the smallest link, it must be less than or equal to P plus Q to obtain the different mechanisms here. So if S is fixed, we are going to see double crank. If S is adjacent to the fixed, we are going to see crank broker. If S is opposite to the fixed, we are going to see double broker here. Okay, so these are the different inversions here. Next part. Yeah, in this case, higher kinematic pair, lower kinematic pair, quick return mechanism, mobility of a linkage. Okay, let us check here. First, mobility of a linkage. Mobility of a linkage is being defined with the help of Kurzweil criteria, or I can say Grubler criteria here. So S is making is matched with the point number 1 here. Second, quick return motion mechanism. Quick return motion mechanisms either used in the planar as well as the shaper here. So it can be marked with the 4 and 5 here. Lower kinematic pairs is having a surface contact. Okay, so it is matching with the 6 here. Higher kinematic pair is going to have a line contact or a point contact. It is matching with a 2 here. Okay, so I can say only 2 6 2651. Option number D is a correct answer here. Okay, option number D is a correct answer in this case. Next part, there is a relationship between the number of joint and the number of links, where L is representing you the number of links, J is a number of joint which constitutes a kinematic chain, and this is given by the expression. First of all, just see. When we talk about the chain, what is the meaning of chain here? That the number of links are being connected in such a way, the first and the last link has to be connected with each other. Okay, now the chain can be a kinematic chain, it can be a non-kinematic chain, as well as it may be a act as a structure also. In the case of kinematic chain, we are going to see that degree of freedom is going to be coming out to be 1 here. That means only one input is being required to control each and every link here. In the case of non-kinematic chain, the corresponding degree of freedom is not equivalent to 1 here. In the case of structure, we are going to see the degree of freedom is equal to or less than 0 here. Okay, so in that case, you are going to see all the frame are acting as a structure here. All the links which are having which require a large number of inputs here, that comes under the category of non-kinematic chain. Okay, now which is one is important for us? Kinematic chain is important for us. So there are a number of ways to find out whether the chain is a kinematic, non-kinematic, or structure chain here. Okay, so here we have one relation which is written as J plus H by 2 equal to 3 by 2 L minus 2. This relation also signifies this equation is also used to find out that whether the chain is a kinematic, non-kinematic, or a structure. Okay, so here in this case you can see, if I assume that there is no higher pair, so I can say J will become equivalent to 3 by 2 L minus 2. Okay, now that is the first thing. So in this case, if the left hand side value of J is equivalent to the right hand side value of the 3 by 2 L minus 2, in that case we assume, in that case we say that our chain is going to be kinematic chain. So we have to satisfy the left hand side with the right hand side here. Okay, in the case of kinematic chain here according to this formula. So after simplifying this formula for a kinematic chain, I can write L will come out to be as how much value you are going to see here? 2 by 3 J plus 2. This formula you are getting here. So I can write option number B is going to be the correct answer here. Option number B is going to be the correct answer here. Okay, now next part. The number of degree of freedom of the figure shown below here is. Okay, let us calculate the number of links first. So here we are having link number 1, link number 2, 3, 4, and 5 here. All the 5 links have been numbered here. Now the number of joints. So here you can see, here we are having first joint, here we are having second joint, here we are having third joint, fourth joint, and the fifth joint here. Okay, and here we are also having a one higher pair. Here we are also having a one higher pair. Okay, so if I just use this formula, F equal to 3L minus 1 minus 2J minus H here. You can see degree of freedom will come out to be as 1 here. Okay, degree of freedom will come out to be as 1. So you have to consider, you have to check out that how many links are there, how many joints are there, and how many higher pairs are there in a mechanisms. Chalo, let's move toward the next part. The figure given below shown has the following details. L1, L1, L1 is this one here, na? This is the L1 here. L1 is given to us 3 centimeter. L2 is given to us 1.5 centimeter. L3, L4 is given to us. The value for the theta 4 when the input link L2 becomes perpendicular to the fixed link for a given assembly mode will be. Okay, so this is going to be a little bit lengthy question now. So it is asking you to calculate the value of theta 4 here, na? Then let us say this is L2, this is L1, this is L3, and this is L4. It is asking you that what is the value of this angle theta. Okay, it is asking you to calculate this value here. How can we calculate this value? First of all, okay, let us do the numbering first. This is our point number O, A, C, B. L1 is a fixed link. Okay, what can I do? First, this angle is going to be 180 minus theta 4. 180 minus theta 4. Okay, now what I am doing, I am just simply dividing this parallelogram into two different triangles here. Okay, so here what can I say? This angle is coming out to be this angle. This angle will be 90 minus theta 4 by 2. This angle will be 90 minus theta 4 by 2. Yes or no? Okay, now because the total inside angle between the OB and BC is 180 minus theta 4, and I have divided that angle into two forms here. Okay, just give me a second. It is not a necessary condition that they are going to be equally divided now. So we also have to consider that part also, because we don't know is it equally divided or not. Okay, so we have to calculate it first. So first, let us calculate the value of AB here. From triangle AOB, we can write AB square will be equivalent to OA square plus OB square. AB is given to AB, we have to calculate OA. OA is given to us 1.5 centimeter. OB is given to us 3 centimeter. Okay. If you just solve it, you are going to find what is the value of AB here. Okay, now. So this will come out to be around 3.354 centimeter AB value. Now, what can we do? Now we can look up in the second triangle, that is triangle number ABC. ABC. Okay. So here we can calculate. So now we know the value of AB, we know the value of AC, and we know the value of CB here. CB also. In this case, this angle is 90 degree. Okay. We don't know the other remaining angles here. First, let us calculate the AB value first. AB. Again, I am writing AB square is nothing, but it is equivalent to AC square plus BC square, AC square plus BC square plus 2AB, sorry, not plus, minus 2AC BC BC cos of angle C here. I can write in this way. So AB value you know, AC you know, BC you know, everything you know. So if you just put all the values in this case, you can find out the value of the angle C. Okay, you can easily calculate the value of the angle C here. So angle C is coming out to be around 52.6 degree here. 52.6 degree it is coming out to be. Okay, now just see. Now we know the angle C, it is coming out to be 52.6. We know the angle O, that is 90 degree here, and now we are going to find out the remaining angles here. Okay, now. So again, coming back to the in triangle AOB, I can simply write tan of alpha. Tan of alpha is going to be equivalent to OA divided by OB. You know the value of OA, you know the value of OB here. I can calculate the value of angle alpha here. Angle alpha is coming out to be around OA 1.5 divided by 3 tan of alpha, and alpha is coming out to be 26.56 degree here. Okay, angle alpha we know. Now the next part, What can we calculate now? Okay, now just see. Now we are going to use this particular triangle again, and I am using the AC here. Okay, now I am using this AC here. I am calculating the AC now. So here I can write AC square will be equivalent to AB square plus BC square minus 2AB BC cos of angle beta. Cos of angle beta. Okay, now? So if you just solve it, you are going to see that cos of beta is coming out to be around. It is coming out to be around 56.012 here. So can I say that angle theta 4 is nothing but it is equivalent to 180 degree minus alpha plus beta. So now you know the value of alpha, you know the value of beta here. Just put all the values and get your final answer of theta 4 here. It will come out to be as 97 degree here. Okay, now? So option number B will come out to be as a correct answer in this case. So you just have to use your basic aptitudes here and nothing else. Next part. A mechanism is shown below. The number of ternary links and the degree of freedom respectively are. Now, what is the meaning of ternary link? So we have seen how many type of pairs are there. We have defined a simple binary joint, quaternary joint, and ternary joint. Similarly, we are having a type of links also. We are having a binary link. We are having a quaternary link, and we are having a ternary link here. First, let me write it ternary link here, and then we are having a quaternary link here. Now, what is the meaning between? What is the meaning of binary? Yes, IOCL में जो आपके पास इंजीनियरिंग पोस्ट जो है, सॉरी इंजीनियरिंग एग्जीक्यूटिव जो ऑफिसर पोस्ट जो है, in that case they can ask you numerically. Okay, but if you are going for JEO post, in that case numerical is not going to be asked here. Okay, few numericals are going to be asked, but that will be only formula based question. But in the officer post, they can ask you simple numericals also. Okay, because you have a lot of time there and the corresponding number of questions are less. So you can expect a numerical questions also. Now, in this case, yes, calculator can be provided here. Okay, but first we have to confirm it again. Okay, but I think they are going to provide you the calculator also. And in case if they don't provide you the calculator, you have to do the calculation by using some assumptions here. Okay, now, because in most of the PSU exam they don't provide the calculators here. Now just see what is the meaning of binary link. So let us suppose if you are having a single link here. Now, if this link can be connected with other links from two different locations, like here you can see the link number 2 and 3 are being connected to a link number 1 at particular location A and B. Okay, so at A point and at point B, only two links are being connecting 1 and 3 and 1 and 2. So number 1 link is going to be act as a binary link. Okay, now let us say if you are having a number 1 link as this one here, this is a complete solid link here, link number 1. Now it is making a connection between with the link number 2, link number 3 and link number 4. So here I can say the link 1 is making a contact with 3 different links. Okay, so that type of link is going to be act as a ternary link here. Similarly, in the case of quaternary link, you are going to see that quaternary link is going to make a connection with 4 different links here. 4 different links here. Okay, 2, 3, 4, and 5 here. So that is going to be considered as a quaternary link here. Okay. Now coming back to in this question here, we have to find out how many. Sorry, we have to find out how many ternary links are there. Okay, so just see. First of all, link number 1. Oh, sorry, just give me a second. Link number 1, link number 1, link number 1. This is a fixed link over. This is a fixed link. Okay. Now, link number 2 is a binary link. Link number 3 is a binary link. Link number 4 is a binary link. Link number 5 is a binary. Link number 6 is a binary. Link number 7 is a ternary. Link number 8 is a ternary. Link number 9 is a binary. 10 is ternary. So now you can see how many ternary links are there. First, the link number 7, because it is making a connection with link number 7 is making a connection with 8, 6 and 1. Okay, it is a ternary link. Link number 8, it is making a connection with 5, 9 and 7 here. It is also a ternary link. Okay, now link number 1, it is making a connection with link number 2, 7 and link number 10 here. So I can say it is also a ternary link. So how many ternary links are there? Ternary links are 1, 7 and 8. Understood? So that's a very simple case. So we also have to calculate the degree of freedom. So we have to know how many joints are there. So let us calculate the joint also. So here we are having first joint. Here we are having second. So this third joint is a ternary joint. This is a ternary joint. Let me write down in this way. So this is a binary joint. This is a binary joint. This is a ternary joint. This is a binary joint. This is a binary, 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 and binary here. Okay. This is also a binary. This is also a binary, and this is also a binary here. Can I say that the binary joints are how many B's are there? 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 binary joints are there. Okay, now how many ternary joints are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And, everything is counted now. Just check it once. Okay. Now, how many ternary joints are there? One ternary joints are there. Do we have any higher pair? Higher pairs are zero. Okay, higher pairs are zero here. So, whenever you are calculating the value of degree of freedom, it is having a formula 3L minus 1 minus 2J minus H. So, there you can see the total number of links are, how many total number of links here? How many total number of links here? 1, 2, 3, 4, 5. Total 10 number of links are there. Okay, total 10 number of links are there, out of which 3 are the ternary link and the remaining 7 are the binary links. Okay, so I can say the number of links are total 10 here. How many total number of joints are there? So there you can see we are having 10 binary joint and 1 ternary joint. So whenever you are using a degree of freedom formula, we always have to consider only the binary joints here. Okay, so you can see the total 10 binary joints are there, and one ternary joint is equivalent to 2 binary joints. So I can say 10 plus 2. Total 12 binary joints are there. Total binary joints are 12 here. Okay, now? And higher pairs are 0. So I can write 27 minus 24. So corresponding degree of freedom is coming out to be 3. So I can write 3, 3 will be the correct answer here. 3 ternary joints are there, 3 binary, 3 degree of freedom will be there. Any doubt in this question? If you have any doubt, please let me know. Chalo. Next part here. Which of the following statements are correct with respect to a Which of the following statements are correct with respect to a inversions of a mechanisms here? It is a method for obtaining the different mechanisms by fixing the different links of a same kinematic chain. That is a correct statement here. Okay. It is a method for obtaining the different mechanism by fixing the same link of the different kinematic chain. That is the wrong answer here. We are fixing the different links of the same mechanism only. Okay, not of the different mechanisms here. Next part. In the process of inversion, the relative motion of the links of the mechanism produced remain unchanged. In the process of inversion, the relative motion of the link of the mechanism produced remain unchanged. In the process of inversion, the relative motion of the links of the mechanism produced will change accordingly. Just see 1 and 3. Yes, in the case of inversions here, always you have to remember the relative motion remains same, but the absolute motion may get changed here. For example, in the case of single slider crankchain mechanism, in the case of single slider crankchain mechanism only, there may be a chance you can fix crank, there may be a chance you can fix connecting rod. Okay, so their absolute motions are changing here. First, when you are fixing the crank velocity will become zero. Okay, and whenever you're fixing the connecting rod, the connecting velocity will become zero here. But their relative motions are going to be remain same. Relative motion means the motion with respect to some other link. For example, if you are fixing the crank here, let us say. Now, if you observe with respect to connecting rod, crank is having some motion here, even though it is fixed. Similarly, if you are fixing the connecting rod, then connecting rod is going to have some motion with respect to the this one here, with respect to the crank here. Okay, so I can say the relative motion remain unchanged, but absolute motion may get changed here. So option number A will be the correct answer here. Okay, now next part. In the electrical tremel, the length of the link connecting the two sliders is 100 millimeter. The tracing pen is placed on the 150 millimeter extension of this link. The major and minor axis of the ellipse stayed by the mechanism is. Just give me a second here. Yeah. First of all, what is elliptical tremel? Elliptical tremel is a simple inversions of a double slider crankchain mechanism in which what we are doing, we are fixing this outside. So I can say we are fixing the outside frame here. Okay. So in this case, we are having a two sliders. We are having these two sliders like in this case, and outside frame is fixed here. Outside frame. This is our outside frame. Black color one is representing the outside frame. Now, why do we use the elliptical tremel? So first of all, what is happening in this case? The sliders are moving either in the vertical direction or either in the horizontal positions here. Okay, so now you can see in this case. So here in this case, also you have to remember, why do we use the elliptical tremor? Elliptical tremors are generally used to, I can say, trace the ellipse here. Okay, we never use it to create a circle. We always use it to trace a ellipse here. How? Just by picking a particular point over this connecting link between the two sliders here. Okay, the point number P, and just by just creating the locus of this point number P, we can trace the ellipse here. Okay. Now in this question, what is given to us? In this question, it is given to us that the distance between point number A and the distance between point number B is given to us as 100 millimeter. Okay. The point P, the tracing pen is placed on 150 millimeter extension of this length here. That simply means now the point number P is not in the middle here. It is placed somewhere at point number C here. So now in this question, you can see BC is representing as 150 millimeter. Now what you have to do, you have to calculate the value of the major and minor axis of the ellipse. So in this case, what kind of ellipse it is going to produce here? It is going to produce an ellipse like, yeah, it is going to produce an ellipse like this one. Like this here. Okay, the point number C. So in this case, you can see point number A, 1, 2, 3, and 4 here. So in this case, what is happening actually? In this case, you are going to see that we are having a certain relations here. Okay. We have a relation like XC upon, sorry, X upon BC square plus Y upon AC square equivalent to 1 here. This is basically an equation of ellipse here. Okay. So in this case, you are going to see that major and minor axis of the ellipse trace now. So this is basically an equation of ellipse we obtain in this case here. If we just go through the derivation here, you will obtain this particular equations here. Okay, so in this case, the major axis is nothing major axis, it is representing you 2 into 250 here. Okay, this line here, this vertical, this line, this is representing you this semi major axis here. This line, vertical line, is representing you this semi minor axis here. So now you can see this whole line, this complete line is representing you major axis, and this complete line is representing you the minor axis here. Okay, so BC is representing you indirectly you the semi minor axis, and A to C is representing you the A to C, or I can say this horizontal line is representing you the semi major axis here. So correspondingly, major axis will become 500 millimeter and minor axis will become It will become here 2 into 150 millimeter, that is 300 millimeter here. Okay. So what will be the answer in this case? Option number C here. So that's again a very simple case now. Now coming back to the next question. The number of degree of freedom for the following mechanism is going to be. Okay. Now just see. In this question first, how many number of links are there? Link number 1, link number 2, link number 3, link number 4, and link number 5. This is a link number 5 here, slider. And this is link number 6, fixed link. So in total, we are having total number of links as 6. How many joints are there? This is a first binary joint. This is our binary joint. This is our binary. This is a ternary joint actually. This one. This is representing your ternary joint here. Okay, now this is binary joint. This is binary joint. Between this 2, 3, and 5. 2, 3, and 6 are meeting at point number. Yeah. This is a ternary joint. And this is known as a binary joint here, between 5 and 6 here. So I can say the total number of binary joints are going to be 1, 2, 3, 4, 5. Total 5 binary joints are there. Okay. Along with one ternary joint is there. So I can say the total binary joints are going to be 5 plus 2, that is 7. Okay, 5 plus 2, that is 7 here. So correspondingly, the degree of freedom will become 3L minus 1 minus 2J minus H. So just put all the values and get your final answer here. Okay, and it is coming out to be option number B only. Okay, option number B only. Next part. Just give me a second. Yeah, now we are having a motion analysis here. Okay, now just see. In the next question, the instantaneous center of a link which rolls without slipping upon another fixed link is being located at. Okay, so actually this particular question is related to the motion analysis here. Motion analysis, and in the motion analysis we have to do the analysis of the velocity as well as the acceleration here. We have to do the analysis of velocity as well as the acceleration. Now acceleration analysis is not so much important for you. You can skip that part here. In that case, in the case of acceleration analysis, you just have to see the correlative acceleration here. You have to talk about the radial, tangential and the radial acceleration here. That's it. Okay, these three terms are important from the acceleration topic here. But when we talk about the velocity analysis here, there we are having two different methods here. First, you have to see the relative velocity method. And the second, you are going to have an instantaneous center method. Okay, so velocity analysis is important for you. You can skip the acceleration analysis. In the acceleration analysis part, just check out the tangential and radial acceleration. That's it. So first, what is the meaning of instantaneous center now? From the name itself, you can define instantaneous center simply means that the point about which a body is having a pure rotary motion at a particular instant of time here. Okay. Center is representing a particular point about which a body is having a pure rotary motion. Yes, mechanism topic is being over here. Okay. Now we are going to move toward the second topics here. Okay, motion analysis here. So in this case, in the case of instantaneous center method, first of all, you have to remember that whenever a mechanism is being running here, okay, it may have a pure translation motion, it may have a pure rotation motion. Along with that, it may have a general motion here. Okay, so generally the pure translation and the pure rotation is very simple to analyze, but the general motion is very difficult to analyze here. So there we have to use the relative velocity method, or you have to use the instantaneous center method. Instantaneous center method is find its usefulness here because it is very simple method here. What does it simply tells you? It simply tells us that instantaneous center is a imaginary point about which we assume the body is having a pure rotation at a certain instant of time here. For example, let us say if you have having a wheel here. If you are having a wheel here, so now you can see this wheel is simply rotating about the center point over here. So if I ask you that where is the instantaneous center is going to be located, so you can simply say, sir, this wheel is being rotating about the point number O. So I can say the O is representing you the instantaneous center. Okay, and that is going to be the correct answer. But let us say this wheel is rotating. Along with that, it is also translating here. It is also translating on a flat surface here. At that point of time where you are going to observe the instantaneous center. Now the answer will change. Why so? Because here in this case, as the wheel is rotating as well as translating over a flat surface, in that case, the instantaneous centers keep on going to be changed here. So how we are going to analyze that? For that, first of all, we have to consider any two random points here. So let us say I am considering the point number 1 and I am considering the point number 2 here. Now you can see the point number 1 is going to have a velocity component like this one and along this one here. This is the velocity component due to the pure rotation. Okay. Now due to the translation, the point number 2 is also having a velocity component along this horizontal flat surface. Okay, V1 dash and V2 dash. So now you can see the 2 points are experiencing a two velocity components. So we have to define the resultant here. So I can say the resultant is going to be this one here, V1 double dash and V2 double dash. Okay. So what I have told you, instantaneous center is a point about which a body is having a pure rotation. Okay. So now you can see if a link is having a pure rotation about point number 1, in that case, any point on any point on any other location, it is having a velocity component perpendicular to the link, and this perpendicular is passing through the center of the link here. Similarly, what you can do, you can simply create a normal line to the velocity vector, and the location where this normal line intersect, that particular point is going to be known as the instantaneous center. Okay, so here you can see whenever a simple roller is rolling on a flat surface, the point of contact is representing the instantaneous center here. Okay, now. So in this case also you can remember one more thing here. The instantaneous center is always going to have a zero velocity here. It is always going to have a zero velocity. So in this case, I can say the velocity of the I point is going to be zero. Why so? Because it is a center point. Or you can also see like in this way, the point number I is experiencing a velocity in toward left side due to the pure rotation, and along with that it is also observing the velocity in the right side due to the translation. So the final velocity, the net velocity at point I will become equal to 0 there. Okay, so I can say in this case option number B, at the point of contact you are going to experience the instantaneous center. Okay, now, but in this question again, if sleeping is there, if slipping is there. What is the meaning of slipping? Slipping means the point of contact is going to experience some velocity here. Point of contact is experiencing some velocity. In that case, the point of contact is not representing you the instantaneous center because it is having a certain velocity here. Okay. In that case, the instantaneous center is going to lie somewhere below the flat surface, like at this particular position I dash here. Okay, remember this condition. Coming back to the next question. A rod of length 1 meter is sliding in a corner as shown in the figure. At an instant, the velocity of the point A on the rod is 1 meter per second when the rod makes an angle of 60 degrees with the horizontal plane. The angular velocity of the rod at that instant we have to calculate. Now just see. So this question is asked many times in the exams here, in a GATE exam, in the ESC exam, as well as in the PSC exams here. Okay, and that's a very simple question actually. So what is actually happening here? So we are having the point A and B. Now, point A is experiencing the velocity. It is moving down here, particularly downward here, with 1 meter per second velocity here. Okay, so now you can see as the point A is sliding in the downward direction, the point B is going to slide outward. Okay, so can I say that we can analyze this link AB about its instantaneous center here? Because if it is an equilibrium condition, so we can say that this body is going to have a pure rotation at a certain point here, at a particular instant of time. So how can we find out the instantaneous center there? So there you will find, if I just simply create a normal from the two velocity vectors here, I will obtain the instantaneous center at the intersection point here at I position. Okay, now so there you will see whenever a body is having a pure rotary motion, in that case, the velocity at any point can be written as omega multiplied by the distance here. So, for example, if a body is assumed to have a pure rotation, pure rotary motion about point I, so I can say VA is going to be equivalent to omega into AI. I can write in this way. And okay now. So, what is AI now? AI is nothing but this is the horizontal component of AB only. So I can directly write omega will be equivalent to VA divided by AI cos of theta. That is 1 meter cos of 60 here. AB cos of 60 here. Sorry. Okay. And finally, the answer you will get as 2. Omega will come out to be as 2 here. Okay now. Or along with that, you can also see if I want to calculate the omega B will be omega multiplied by BI. So you know the omega. Now what is BI? BI is the vertical component of AB. So I can write 1 into sine of 60. It will come out to be as root 3 meter per second here. Okay, now? So remember this condition now. Now the next part. So in this case, option number A will be the correct answer. Okay, so this is going to be the last question here. The remaining question of this particular chapter here, we are going to see tomorrow at the same time. Okay, now? So in this question, what is given to us? A point B on a rigid link AB moves with respect to A with the angular velocity of omega radian per second. The total acceleration of B with respect to A will be equal to. Okay, now just see the concept of acceleration. Actually, what happens whenever you are having a link? Now, whenever the link is being rotating about a certain point, let us say we are having a link AB, okay, and the link AB is rotating with a certain omega here. So there you have to understand first that omega is a vector quantity. It may have a magnitude, it may have a direction. Okay, so in this case, first I am assuming the magnitude of the omega is constant. Omega, magnitude of omega is constant here. Okay, it is not varying. In that case, you have to remember the link is going to rotate uniformly about the point number B here. Okay, and if you just see, if I define the velocity of the point A, the velocity of the point A is going to be written as omega into AB. Okay, so there you will find omega will be constant, AB will be constant. So correspondingly, the magnitude of the AB will be constant here, but direction of the AB is continuously changing here. because after a certain instant, the AB link will become inclined. Then the velocity component will become, the velocity direction will become change here. Okay. So you have to remember that whenever a link is rotating with a constant angular velocity, at that point of time, the velocity of a particular point, it is going to have a constant magnitude, but the corresponding direction is going to be changed here. Okay, that is the first thing. So due to the change in direction of the velocity, we are going to have a radial acceleration here, or which is also known as the normal acceleration. So in this case, whenever a link is rotating, then velocity is always going to have, the velocity direction is always going to be changed here, no matter whether the omega is constant or changing. Okay, so we are having a radial acceleration along the length, along the link here acting toward the center. And if omega is changing, for example, during the starting of the motion or during the ending of the motion, omega may get reduced. So due to that, omega will change. If omega is changing, the corresponding magnitude is also going to be changed here. If omega is changing, velocity magnitude will change here. Okay, due to the change in magnitude, we are going to experience the tangential acceleration. So tangential acceleration depends upon in which direction the angular acceleration is taking place. Okay. So there you have to remember that radial acceleration is having a formula of omega square into distance. Okay. I'm assuming r is the length of the link here. And tangential acceleration is having a magnitude of r into alpha. Okay. So radial acceleration always act toward the center. Okay. Tangential acceleration always act perpendicular to the link here. And the direction of the tangential acceleration depends upon whether the omega is increasing or decreasing, or I can say it depends upon the direction of angular acceleration. Okay, that you have to remember. So there may be a chance omega is not changing, there may be a chance omega is changing, but the direction is always going to be changed. So that is why we say that radial acceleration is always going to be present in the rotating link, but tangential acceleration may or may not be present in the case of rotating link here. Okay, so you have to remember the rotating link is going to have experienced two type of accelerations here, radial as well as the tangential acceleration. One is acting vertically and one is acting horizontally. So if I have to calculate the total acceleration then, total acceleration. So now you can see the two accelerations are perpendicular to each other and they are vector quantities. So we have to square them and add them and take an under root here. Then only we can solve the problem. Okay, so now you can see the total acceleration of the B with respect to A or A with respect to B. It is going to be a vector sum of radial component and tangential component. Okay, now. So in the question, they have, see, out of all the topics here, okay, theory of machine find its weightage up to 5 to 10% here. Okay, now. So maximum, I suppose you are going to see the question related to the production part, then I can say thermal engineering part, then theory of machine part, and then strength of material part here. Okay, now. So option number C will be the correct answer. Okay, so that's it for today's class here. Now the remaining questions we are going to see tomorrow. Okay, and tomorrow we will see the concept again of the velocity analysis as well as the acceleration analysis here. Okay, now. So if you have any doubt, please let me know. Then I will close this session here.